Chapter 10, Section 6, Making Decisions and Predictions. The objective of this lesson is learning to find the number of possible outcomes in an experiment. Phone numbers have 10 digits beginning with a 3-digit area code. This results in over a billion possible phone numbers. The fundamental counting principle. If there are m ways to choose the first item and n ways to choose the second item after the first one has been chosen, then there are m times n ways to choose all items. Using the fundamental counting principle. A telephone company is assigned a new area code and can issue new 7-digit phone numbers. All phone numbers are equally likely. Find the number of possible 7-digit phone numbers. Use the fundamental counting principle. For the first digit, there are 10 choices. We could have numbers 1 through 9 and 0, so for 10 choices. The second digit, the same. We could also have 10 choices because the number could be repeated. The third digit, we would have 10 choices. The fourth, the fifth, the sixth, and the seventh digit each could have 10 choices. So to calculate the total number of phone numbers, we would take 10 times 10 times 10. We're going to do that 7 times. Please calculate that answer and write it here. The number of possible 7-digit phone numbers is, you just calculated that number up here. Please repeat that over here. Now we're going to find the probability of being assigned the phone number 1, 2, 3, 4, 5, 6, 7. So the probability of the phone number 1, 2, 3, 4, 5, 6, 7 would be 1 out of how many possible phone numbers? Please write that ratio here, and then please calculate that as a percent here. The fundamental counting principle tells you only the number of outcomes in some experiments, not what the outcomes are. A tree diagram is a way to show all of the possible outcomes. Now, using a tree diagram, let's just say that you have a photo that you want to mat and frame. You can choose from a blue, purple, red, or green mat and a metal or wood frame. Describe all the ways you could frame the photo with one mat and one frame. You can find all the possible outcomes by making a tree diagram. Each branch of the tree diagram represents a different way to frame the photo. We start off with the photo. We could have a blue mat, and with that blue mat we could have metal or wood. We could choose a purple mat instead, and the choices for the frame would be metal or wood. A red mat, the frame would be metal and wood. A green mat, metal and wood. The ways shown in the branches could be written as blue metal, blue wood, purple metal, purple wood, red metal, red wood, green metal, and green wood. Now notice that with the mats we have 4 choices. With the frames we have 2 choices. So for a total of 4 times 2, we would have 8 different possibilities. Blue metal, blue wood, purple metal, purple wood, and so on. There should be 4 times 2, which would equal 8 different ways to frame the photo. The number of mats, colors are 4, the number of frame choices are 2. We're going to use the tree diagram for dependent events. Let's say that there are 7 black socks and 2 white socks in a drawer. If 2 socks are removed, what's the probability that the colors of those socks match? A pair of socks in the same color is a match. After the first sock is selected, the probability of selecting another sock of the same color changes. They're dependent. Complete the tree diagram below, showing the probability of each outcome. Alright, for the first sock being chosen, there are 9 choices because there are 7 black and 2 white socks in the drawer. So we're going to look at one scenario first. That being if we reach in and pull out a black sock. The probability of us reaching in and pulling out a black sock is 7/9. There are seven black socks and a total of 9 socks altogether. Now if we choose a black sock first and we move to our second choice, the number of socks that remains has changed. It was 9, but that first one is gone, so now there is a total of 8 socks. If the first sock was a black sock and there are a total of 7, there are no longer 7 black socks in the drawer, there's only 6. So the second choice for my sock, being black, would be 6 out of 8. Now, for the first choice being black and the second choice being black, we're going to multiply to find each of those outcomes. So we take the first probability of the black sock, which is 7/9. We're going to multiply that by the probability of the second sock being black, which is 6/8. We're going to multiply those together, write that product here, and then simplify that and write that simplified ratio right here. Please do that. Another scenario is that the first sock is black, which would be 7/9. That would be the probability. On my second sock, I could end up pulling out a white sock. The probability of me pulling out a white sock on the second draw would be 8 for a total, and there are still 2 white socks in the drawer. So the probability of the second sock being white would be 2/8. So a black sock first and then a white sock. Over here, I would multiply those probabilities together to calculate the probability of a black sock drawn first and a white sock drawn second. So 7/9 multiplied by 2/8. Write that ratio here and then simplify that ratio. Another scenario is for the first sock being drawn, it could be a white sock. Again, when I reach into the drawer for the first time, there are a total of 9 socks. Of those 9, 2 are white. So the probability that I would draw out a white sock would be 2/9. My second sock could be a black sock. Now, remember that the total number of socks has changed, but in this scenario, a white sock first and then a black sock, the total number of black would remain at 7. So please write that ratio here. Now I would know first sock probability is 2/9. You just calculated the second sock being black, that probability you wrote here. Take these two probabilities, bring them over, multiply them, and reduce that ratio. The last scenario would be a white sock drawn first, which is 2/9, and my second draw would be a white sock. Now remember, in your second draw, there's only 8 choices left, so that's our total. When we began, there were 2 white socks, but my first white sock is gone. So that number of white socks remaining has changed. Please fill in this ratio, bring these 2 probabilities over, and multiply and simplify that ratio. Now, what is the probability that the colors match? Go back to your tree diagram and remember that matching colors need to be black, black, or white, white. And they are mutually exclusive events. They cannot occur at the same time. So you're going to add their probabilities. So go back to the tree diagram and you're looking for black, black. What's that probability? And white, white. You're going to bring those probabilities over here. You're going to add them together and then write that answer as a percent.